So let's talk through some 7.1 notes. Well, first, really all we're doing in this section, let me go back here, is we are using these identities to prove things. So first, let's just remind ourselves of some identities. The tangent is sine over cosine. Cotangent is cosine over sine. Sine is 1 over cosecant, because S goes with C. Cosine is 1 over secant, because S goes with C. Tangent is 1 over cotangent. Well, then relatedly, because S goes with C, cosecant is 1 over sine, and secant is 1 over cosine. Well, then also cotangent is 1 over tangent. And so we need to know all of those reciprocal identities. And then also we know that sine squared plus cosine squared is equal to 1. And then from that, we also get that tan squared plus 1 is secant squared, and 1 plus cotangent is cosecant squared. Then from this, we should also notice that sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared. And if you wanted to know where this sine squared plus cosine squared equals 1 came from, cosine is just the x, and sine is just the y on the unit circle, so we quickly get a right triangle and see that cosine squared plus sine squared is equal to 1 squared, which gives us the identity. So let's see if we can't use our identities to verify things. First thing we're going to verify or prove is that secant alpha minus cosine alpha is equal to sine tangent. And we remember the really important thing on these is to start with one side. So we start with the left-hand side, secant minus cosine. And we know that one really big hint is to get everything in terms of sine and cosine at simpler parts. When we do, we get this, and then, so now everything's in terms of sine and cosine, right? Well, then it's really important to see cosine just sitting by itself as cosine over 1. Well, when we do, we now see that since that's cosine over 1, if I want to add these fractions, I have to get the same denominator. So we use this well-chosen 1 to get cosine on the bottom, and so this is 1. Cosine times cosine is cosine squared, and now both these fractions have the same bottom of cosine. But then we know that 1 minus cosine squared is just sine squared. And then if I factor this out and break into pieces, I get sine times sine over cosine, but that just gives me sine times tangent, which is what we wanted. So we have now proven that the left-hand side equals the right-hand side through a series of equals, and that's all we wanted to do. A lot of these moves happened because I was going from 2 terms, and I know I wanted 1 term. That's why I added those together. Then at the very end, I knew I wanted cosine on the bottom, because sine over cosine is tangent, and so we worked to there. Now let's say I had to verify this thing, so secant equal to all this garbage. Well, I think it makes more sense to start with this side because there's more to work with. So I'm going to start with the right-hand side, and hopefully through a series of equals, I can get all of this to be equal to secant. Well, the first thing I might do is get everything in terms of sine and cosine, and that's what we do right here. Well, then after that, we can distribute sine to hit that term, and it gives me sine squared on top, because that's just sine over 1. So on top, I get sine squared. On bottom, I get cosine. But then we distribute through to here, and now on top, I get sine over cosine, and on bottom, I just get sine. Well, the great thing about that is that I think you'll notice real quickly we have a sine on top and bottom. We can cancel those out. And so now we have this, but then we want to add those two because we know we wanted to get it to be just one little old term secant. So since cosine is the same as cosine over 1, then I can multiply by cosine over cosine and get this. But then I have memorized that sine squared plus cosine squared is just 1. But 1 over cosine is secant, and we're done. Okay. And for the last one that we might do today, let's say that I had to verify that this fraction is equal to that fraction. Well, I'm going to pick a side. I'm going to start with the left. And notice what happens when I start with the left. I wish that it looked a little more like this side. When I look over here where I'm trying to get to, I have a 1 plus sign on top. So if I take this, what I'm starting with, and multiply it by 1 plus sign on the top and the bottom, well, that's just a well-chosen 1. So on top we get this, but on the bottom, notice what happens. If I were to multiply out those binomials, on top I would just get cosine times 1 plus sign. But on the bottom, 1 times 1 is 1. 1 times sine is sine. And then there's nothing left to multiply 1 by over there. Well then, negative sine times 1 is negative sine. And then sine times sine is negative sine squared, because it was a negative there as well. Notice what happens nicely. These cancel out, and that's always going to happen if you have some two terms and you multiply them and they have different middle signs with a minus and a plus. So anything that is of the form a minus b times a plus b is always going to give you the first one squared minus the second one squared. That's what's called the difference of two perfect squares identity. It's always true. So now once we're here, we hope that we can simplify it further. And I know that 1 minus sine squared is just equal to cosine squared. That's one of those identities that we talked about that you had to have memorized. And why that's great, one of these cosine cancels out and leaves you with just 1 on the bottom, and that's what we were trying to show. And that's the sort of stuff we're going to do in this section. Let me know if you have questions.